Hey, my name is Michael Haig. I am here to talk about a little bit of my workflow when a new tool comes out and related to an old piece of security content I created at Splunk. Going to deep dive into that. Going to use a recently released atomic test harness called LSASS dump. And yeah, let's just get on into it. Thanks for joining. All right. So I'm going to dive in related to how I took a previous blog post or cancel, restart. 5, 4, 3, 2. All right. So back in April, I wrote a blog post on granted access into the LSASS process. And it's a great blog post. We utilize the Atomic Red Team T1003-001. And within that atomic test, there's multiple tests that attempt to dump credentials through LSASS. And we take our old analytic that we had here, which was just looking for a target image of LSASS and these two DLLs in the CallTrace. And this is using event code 10, which is access request with Sysmon. And so I went through and I ran through all the atomic tests and I captured the granted access, which is all the values right here. You can see the hex numbers. And with that, I created a new analytic that basically was able to produce a different output than what we had based on all the different tools. And so down here in this blog, I highlight the different access requested, what their call trace looked like, the tool or what process it was based on, the behavior that I was performing with it. And you can see all the requests here. And so I took that and then we modified our analytic to look a little bit more, like it was using different requests or different access granted plus different pieces within the call trace. Well, Red Canary, Johnny Johnson, recently published a new atomic test harness called Dump LSASS. And it's basically just a more abstracted way to test dumping credentials within LSASS. The parts that I want to highlight here that are far more in detail than what we get from just the atomic tests that are there are the ability to specify different access rights that you're requesting for your process to go inject into LSASS for the dump. So that's a parameter that you can hit with this. There's different variants in here. I'm going to scroll down just to kind of show exactly what those are. And there are some good examples in here. But some of the money shots you want to go after here, and I'm going to highlight, is this piece right here. When you hit the parameter variant, it has multiple variants, and this is on line 265. It's using debug help, debug core, kernel 32, API, MS win, things like this, right? But it's going to call out a couple things that I didn't add to our initial analytic when we shipped. You'll see NTDLL, kernel 32, kernel base, and then there's duplicate handle in here. So keep that in mind, what this is. And then down on line 270, these are the requested access, so the access rights that you're going to use. And so all access, which we call out in the blog, is just all Fs, and then all the other variations. Now, the cool thing here, you can see some of them he tied together here, and same with this one. So two different ways to request the type of permissions into LSASS. So remember this as well. We'll go into this in just a minute. So I'm not going to go into detail of everything that's in this atomic test harness, but I just wanted to call out those two lines as far as what the variant parameter does and what the access right parameter does. Now, To install atomic test harnesses is just as easy as you would atomic red team. You can actually just do a simple PowerShell gallery install module. And then there's also, you just download it and just import it directly, which is basically what I did for my demo here, which gives you, the latest of atomic test harness. All right, so I'm just gonna pull up PowerShell. I'm in the folder. The quickest method to kind of cycle through atomic test harnesses is Invoke ATH. And you can see here, you will receive all of them. And obviously the one we're looking for is ATH dump LSASS. I'm gonna run it. This is just like the demo or the screenshot that Johnny had shipped with it as well. So if you hit enter here, it will go through and give you a sweet output here, telling you which source image or source executable, PWSH, PowerShell, the granted rights that were requested in like human readable form, and the target image, which is LSASS. And then you'll also get a dump file, which, either means this was very successful or, it actually worked and whatnot. But remember the variant here. So the default variant was using debug help. Now remember, we have different parameters that we can use here. So we can kick this one off. You could do Debug Core. Let's just run that one for funsies. I'm gonna also just run one more. Oops, I'm gonna run one more here so that we can see a couple more things in here. Duplicate handle. All right, no output. Interesting. Not sure I want to solve that just yet. All right, so that's that, right? So as I mentioned in the blog, we have all these granted access types here, and up above that we actually showcase sort of the details of what each one is right up here. So the values and what they mean, very similar to what you see in the atomic test harness itself. All right, so I'm gonna flip over to Splunk. This is our base query looking for those granted access plus these particular call traces. I'm going to change the time to just 5 minutes because we're within that time frame. All right, so here we are. So based on that, we ran a couple tests. We ran 3. We know that the PowerShell process is going to request access to LSASS. And we see 2 things here. We see the full request and then we see the 1410. And so the 1410, which I call out in the blog here, is sort of like a very common access request, which is, again, process query limited and process query information. So that's kind of where all this ties up, right? So if you combine the 1000 and the 1400 and the 10, that's where you'll end up with these values. Actually, it might be 3 of them, 1400 and the last one here, the read 10. So you combine those, that's where we're getting this value from. So as I was playing with the test harness, I realized that we were missing something here. We're missing kernel base and what was the last one? We'll show it here in a sec. But in order for me to see all that, I needed to understand the CallTrace. So what I did is I removed the values I had in here and I put it down here in my stats to show the CallTrace explicitly. Because I really wanted to see like what the exact target or the source image PowerShell and what it was using. And so I already had NTDLL, but I did not have kernel base in my CallTrace before. So not any set of a deal breaker. And then something as I was looking at this was, well, if I want to make this more high fidelity, I will probably want to remove NT authority system as the source user. We'll leave it as the target user because LSASS obviously runs as system. So let's remove source user. And I'm going to put this one in here. And there's going to be another one for network here in a minute. We'll get rid of that one. Yeah. Just so these are out of our way. We don't have to worry about them and the noise that they generate. Get a little extra break. Done. So now it's getting a little bit tighter. We have our 2 tests. We have our full access and our 1410. This is looking a lot better now. And you'll notice the count is 2. So most likely each test actually requests both. And to validate that, what I would do is just look at based on time. You can add time here instead of at the end, and break them up and so that you can see each individual event and when they occurred. That's probably the fastest way. Obviously the source process ID is going to be the same. And yeah, so based on that, I want to add back the CallTrace values. So I'm going to bring this back. CallTrace, we need to remove or add in our source user piece back in here again. So I'm just going to retype this, not source user. Actually, let's bring this up one more time. I think what we want to do is just go ahead and add in kernel base in here. And then what I will do is say not source user. Oops. And just copy system and network authority out. Now, if the adversary is truly running a elevated state system, they most likely won't need to dump credentials because they probably already have them. But that would be the other kind of like inverse method of going after this particular behaviors. We would want to know from all angles, how that is looking or how that is working. All right, so I messed something up. Let's see. Let me just remove this real quick. Oh, within our time window here. I'm just going to do 60 minutes because we have enough data in here now. Okay, so there they are, the 2 that we're looking for. So from there, I'm going to go ahead and just start flipping through the variants here before I start messing with the different access, granted access. Confusing all the words together, but granted rights. So we already did all those. Duplicate handle, let's do kernel 32. The other one that you could go after as well, and you could wait a certain amount of time for these and then kick these off just so you don't have to like bake these all together real quick. So when I hit enter here, we'll be able to see this. All right, I'm gonna go back to the atomic test harness real quick because there is those items I mentioned. So if you come back down here, we talked about Debug Core, kernel 32. This one I'm interested in what it looks like, what we're missing, kernel base, kernel 32, NTDLL we already have. So back here, we see again, it's still using the same granted access. So I'm not too concerned if I'm missing something, but I probably am. So let's back this out and add back the CallTrace in our stats. When this comes back, we should see hopefully something different, but we're not. So makes me think based on the requests we have set in here, we probably should start changing the granted access rights. So let's flip back to access rights. I'll cycle through everything for fun. There you go. So there's all access, which is going to be your Fs, query information, query into virtual memory read, things like that. So let's just kick it off and see what we get. And then for fun, so note that this one is going to use kernel 32. I'm going to do that one as well. And then I'm going to do one more. Let's try that. There. Get an access denied. So there's not enough permissions for using kernel 32 to inject and dump credentials that way. All right, so hit this. And this is what we get when it loads up. Slowly. Okay, and so now the data showed up. Now remember, we changed the requested access, and so here we are. So ntdll, kernel base obviously is in here. So we got a 1010 and a 1000. If we look back at our blog, process VM read would be your 10, and your 1000 will be in here as well. Let's see. Oh yeah, right. Process query limited info. And what did we say? 1010 and 1000. That's what we had in there. Yep. So process limited. So perfect. So that's exactly the type of what we wanted to see, more or less, right? I'm going to back this down real quick. Let's go back to Debug Core, access rights, and let's do that one. Okay, and rerun that. There you go. And again, these are going to be combined, so if we will get some staggeredness based on that. It could be down in this one, or because it has Debug Core already, but that's full access, and then your 1410 and whatnot. So yeah. Anyway, so the idea was that, based on some new testing and the prior work that I've done in here, is that we're able to see that Debug Core, Debug Help, ntdll, kernel base, all of these are still valid. There's obviously some adds that I did in here. I removed the user because I wanted it to be a little bit more high fidelity based on a user account or an administrator account, whatever it may be, dumping credentials. I wanted that to be in there. I think it's going to be more, like I said, higher fidelity using this without the source user system or network service. We may miss an adversary who has system dumping credentials, but if they already have credentials, you got other problems. So yeah, I added that. And then just triple checking kernel, see kernel 32. We didn't run that one. Let's do it. So let's go back. Oh, we did. Kernel 32. Wait a minute. We didn't do create tool help 32 snapshot. Let's do that. So back to this. Let's do kernel 32, create tool help. Let's just run that. See if it works. Yep. Cool. So query info and virtual memory read. So that will fall into our standard path of, the requested access in here will be pretty normal here. So yeah, nothing new. And something that I want to clean up here, this really bugs me. Source image should come before target image. And so that's just a cleanliness thing. I'm going to fix that right here. So just bring that back there, comma, get this over here. There. So now we will have source image that's performing the task into LSASS with the requested permissions. And we removed NT authority, system, and network service. So those two, it's just a little bit cleaner now. And now we can see what was truly going on. Process, hitting LSASS with what permission set. The other thing I want to clean up is LSASS is always typically LSASS, and so I don't think there's a need to just do wildcard LSASS, so I'm going to add the wax right here, the slashes, so that it just, I don't know, maybe there's something performant in that somewhere, but that's a little bit cleaner. So yeah, we really cleaned this up. So again, taking this blog from April and a new test harness from Red Canary Threat Research, we went through, again, validated the query that I did ship back in April. Works pretty good. It does catch a lot of the things, either from Atomic Red Team, but also the Atomic Test Harness. And then we went and we cleaned up the query to add some new CallTrace DLL names, which would be kernel based in here now. And I also removed the source users of system and network service. And we added the slashes here, and we cleaned up the formatting to show source image first before the target image. So yeah, awesome. Okay, so before I cut the vid, I wanted to at least show sort of what the module loads look like from PowerShell. So this was just a few minutes ago, about 3 minutes ago. You'll see kernel base loading into PowerShell. We will see Debug Core and Debug Help in here. Obviously NTDLL. All those module loads will be right here. That's sort of the difference of when that is a way to go after detection for these things, but I wanted to at least show, you know, where these fit and how it looks. And then this particular dashboard is on my GitHub repo under my notes repository, and it just kind of breaks down each of these sysmon different sysmon data sources, so you can see all the different access types and requests, things like that, file mods and whatever it may be, network connections and everything like that. So yeah, that is that. So is yet another way to look at it, just a different angle with the module loads going into the PowerShell process. Well, thank you for listening. I hope this was informative in understanding sort of the workflow that I take when something like a new tool comes out, even if it's more of like an actual credential dumping utility or an atomic test harness. That's how I use it. And thankfully with things like this where we have the source, we can quickly go in here and see what we can, you know, see how this thing actually works, what it does, what it's using, and whatnot. So hopefully this was valuable to you out there. Thanks again.